and we're going to be doing Lifting the Future, Heavy Lift, Long Endurance, and Cargo Drones, Reshaping Energy Operations. So this is a lot of what we use on a day-to-day basis. How are the use cases developing? How's the technology developing? Panels coming on up, and we're going to be seeing various perspectives, and this is everything from the larger payloads that are needing to be lifted, for cargo drones that are starting to be utilized throughout different regulatory schemes. So this is a lot of information on how we actually can operate safely and better. So I'm going to be turning it over to Michael Hill, who is going to be our moderator today with our esteemed panel, and they will introduce themselves. We've got some cool videos, cool slides, and I think it's a great last session. So enjoy, and we'll have Q&A in just a bit after they finish. Michael, to you.
Good afternoon, everyone. Thank you for coming. So I'm Michael Hill. I'm a professional drone pilot. Just celebrated my 10th year in the industry, operating under FAA regulations. I've specialized in heavy lift, complex UAS operations, particularly in energy and industrial environments. I currently lead the drone technology program at Dallas College, where we're building out the nationwide workforce development program there. And I've helped launch one of the most interesting and complex operations using heavy lift UAVs in multiple environments offshore as well as here on the ground. So my work sits at an intersection of real world drone technologies and regulations. So we've got a great panel up here today. I want to take a few minutes and let you guys each go through and introduce yourself, tell them what you do, and why we're here today. Welcome.
Hello, can you hear me? Hello, my name is Mark Zimmerman. I'm a co-founder of Phoenix Solutions. We make, as everyone talks about it, a heavy lift drone. Our drone is 3,000 pound maximum takeoff weight with a plus 1,500 pound useful load. We're using this conference to introduce our drone to the energy market. We've been spending most of our time in the military and in overseas aerial firefighting.
Hi, I'm Gekman Chetin. I'm leading the international sales and business development of Access Technologies. I'm an electrical engineer, and the majority time of my professional career I have been in the utility business, providing substations, turnkey, and power products to major utilities around the world. And also, before I joined the drone business, I was in the renewable business, providing carbon neutral cycle converters. And now I'm in the drone business, and we have a heavy drone which can fly for a long time. I will introduce that just in a time. And we are serving mainly into the oil and gas and utility business.
Everybody, Kyle Miller, Census Technologies. I'm our sales director. For the past 7 or 8 years, 9 years, I guess, Census has been harping the beyond visual line of sight story. We are vertical takeoff and landing fixed wing, far from heavy lift, 5 or 6 pounds instead of 3,000. So we're definitely not the heavy lift group up here, but definitely on the longer endurance side than what the industry's flying a lot of these days on the multi-rotor, kind of workflow. So looking forward to talking about some of the concepts and topics today. So thanks, Mike.
Great. Michael, thank you for having me today on the panel. My name is Andrew Aubrey. I'm working with a company called Skyways out of Austin, Texas. Skyways is making high endurance, long range drones. Mainly we were funded by the military for the past 5 years. So we've got a very strong DoD program going. We're here to learn. We were at AUVSI and now we're here at EDRC. We're here to learn about commercial use cases and see where we can apply our high endurance drones to the industry.
Thank you. So you see there's a wide diversity of what could either be long range or heavy lifts. So, and that was one of the conversations we had in the hallway here about heavy lifts. So what I'd like to do is start with you, Mark, work down the panel. I would like to see, I'd like to understand what your perspective is as a solutions provider of what you see as a heavy lift long range aircraft.
Well, I guess from our perspective, so I come out of traditional manned aircraft. So, I guess I tend to always go back to the FAA manned aircraft rules of Part 27 being a light utility aircraft, which is the same sized aircraft that if you were to have a loved one taken to the hospital, that's a light utility aircraft. Further heavy lift would be a Part 27 like a Black Hawk, a Chinook, or more traditional larger aircrafts. So coming from the FAA environment and providing products to that industry, we took the approach that heavy lift to us was literally using a drone to do the dull, dangerous, and dull work that a current manned aircraft does. So our philosophy is 3,000 and up. So we developed a scalable heavy lift technology that the Ultra 2XL is the high volume part of the market. That's our market entrance. And we have scalable technologies to a 4, 6, 8, and 10, and just put thousands of pounds on those numbers. So that's where we're headed from a heavy lift standpoint for both military and civil use.
Thank you. Gern?
Yeah, from our point of view, we focus on inspection. So many energy companies want to know how the actual health status of their assets are. And what does that mean? You need to have qualitative data, which gives you insight. And you want to have that data in a cost-effective manner. And that's what we provide. We enable as heavy lift to carry heavy lift sensors, which weigh below 6 pounds, something between 4 to 6 pounds.
Yeah.
And then also to carry them longer than traditional drones out in the market today, coming close to helicopters and replacing them, meaning you do the same inspection at a fraction of the cost. That's for us heavy duty, long endurance.
Kyle?
Yeah, so long endurance for us is a little different because we're entirely electric. So we've wanted to always remain entirely electric. Obviously, going to a hybrid power plant offers a lot of advantages for range and endurance and miles per day. We spend most of our time in energy and transportation, so traditionally competing against, like Gokman just mentioned, on the helicopter side. But often what we're also trying to unseat, or I don't really like the word unseat, it's more augment or provide another layer of a remote sensing puzzle, is satellites, is walking inspections, is driving inspections. These are the things that we're actively working on replacing or making more efficient, or replacing dull, dirty, dangerous. Well, a walking inspection along a right-of-way is pretty dull, dirty, and dangerous. So those are the types of things that we're looking to replace, whether it's vegetation encroachment practices or what have you. In 2 to 2.5 hours, I think Census takes the opinion that long endurance is relative to the use case, to the customer, to the maturity of the program, to the size of the problem being solved. And so, again, it's the kind of ballpark that we're in.
Yeah, that's a good one. Good answer.
Yeah, and I'll finish up here. So Skyways, we're taking an approach. We're not jumping right to the heavy lift vehicles. Instead, we're taking an incremental approach. So our version 3 bird right now, Skyways UAS, can carry 30 pounds for 8 hours or 500 miles. So that's what we consider more of a moderate payload. And
Serious heavy load.
There you go. There you go. Well, our version 3 is 100 pounds. So that's getting us up there to some of the other vendors that are working. But what we're trying to do is we're trying to alleviate a lot of the helicopter traffic by using our useful load, our 100 pounds, to start chipping away at that total duty for the helicopter side. So we know we can't accommodate everything at 100 pounds, but we can do a lot of flights and get that number up very high. So that's what it is. It's really an on-demand resupply with a moderate payload is the approach that Skyways is taking. When you ask me what true heavy lift is, I mean, I think you're seeing it right there.
Yeah.
At, 1,000+ pounds.
Variations of it.
Yes,
Yeah.
yes. So I would say that I think you're going to see this incremental approach adopted pretty commonly, like we are. And version 2 is about half the weight and half the specs as version 3. So you can see our trend for sure.
Nice. In compiling these questions together, this is one I want to touch on with you guys, but I want to start with you, Kyle, with the Centero 6 and Centero 5. I have experience in those aircrafts, but I really would like to throw this question at you. You know, how has the demand for your heavy lift or long range drone in the energy sector evolved over the last 2 to 3 years? So over your evolution from Centero 4 to 5 to now to 6, how do you see, you know, some of those clients like AEP and that, how do you see that's developed and helped you with your technology as you rolled from 4 to 5 to 6?
Yeah, I think we're generally in the part of the adoption curve that is kind of that early majority. I don't think anybody's coming to this conference to answer the question of are drones valuable in their enterprise. It's what are the use cases and how can they be used, and more importantly, you know, how do we handle the influx of new data that we're receiving?
Yeah.
That's the, you know, the back end we solve, or that's what we're solving for now. You know, the collection side is kind of getting there. It's pretty standardized at this point between the training ecosystems, the regulations, the technology. Everything's kind of working in harmony for, I don't want to say the first time, but this is the best it's ever been when it comes to everything kind of working together in concert under Part 107 and under waiver, things like that. So we start to see this adoption from, you know, you mentioned the electric utility side. Really, it's getting these use cases kind of validated across different business units. I mentioned vegetation earlier. That's been one that's been gravitated to. Storm response has been something that's been gravitated to because it's obviously hyper valuable and useful to gain information about your assets after a weather event. But getting them into the routine line, you know, the routine operations between transmission and distribution, I think is that's what's created, because that's where the big budgets are. Yeah. You know, the transmission guys and the distribution guys, those guys have the budgets that they are either looking
and the
to,
safety use case too, right?
Exactly.
We've seen that evolve over the last few years dramatically.
And you know, you bring up a good point about kind of those steps to get from technology steps, those processes to get there. You know, Centero 4 had a 3-mile range. Yeah. That was 2019, 2018. You know, at the time people were like, "Ooh, we can go 3 miles." We're used to only going 1. Yeah. 3 miles is kind of lame now. Yeah, it is. Centero 5 had a 40-mile range for the first time. And, you know, people were able to start doing point-to-point missions, and okay, now I can do over 100 miles per day, maybe 150 if I have enough crew, and you know, but the pieces of the puzzle were starting to come together. And then really, you mentioned the Centero 6. All that is a bigger plane. It's 2.5 hours instead of 1, and multi-sensor instead of 1 sensor. So now you have information getting disseminated to multiple business units. The veg guys get the information they need, and the comprehensive visual stuff gets done for the transmission directors as well. So you know, we're starting to see that a single flight cater to multiple use cases across multiple different business units, and that's when the dollars get thrown at it to scale.
Nice, yeah. You know, so having a relationship with XCR, I love your platform. I'm curious how you see the advancements in AI affecting your aircraft and your solutions, not just now, but a couple years from now. How do you see that's going to evolve you in what you're doing?
I mean, there are 2 points when we speak about AI. One is using it while you're flying, and the other one is using it after you have collected the data. And Kyle mentioned it right. We are collecting nowadays with the long-range drones so many data, and how do you handle that data? I mean, you don't have enough workforce really at the customers. You throw them data, and they're like, hey, do it a little bit slower, please. I need to handle that data somehow. And this is where AI comes into picture. So AI will help in future, or helps already today, to annotate your faults, to find the issues, and then to make a report out of that. And that is happening today. And that gives all the drone manufacturers more business, because they need then again more data, and we need to fly again more. So that's happening today. When I look to the future, I mean, now new regulations are coming. So we want to get more BVLOS stuff happening. And what does that mean? You fly over people, you fly in airspaces where other things fly, which don't have any remote ID. So what are you going to do? You need to detect them, and there AI will help to do visual video detection of other objects, and we are working on that. So we are day in, day out now testing a module to have 360-degree AI detection of other objects. And once we have all the data collected, we will have a detect and avoid system on board to get faster BB loss approval.
Yeah. Great question. Great answer.
Thank you.
So, you know, I was thinking about a couple things. You know, one of the things I talk about a lot is cybersecurity and the lack thereof. And so it'd be interesting to see how the advancements in AI affect that overall. Mark, I wanted to ask you a question. So with your platform, what would you say over your last few generations have been the most significant technological advancement in your solution, in your aircraft? Has there been one?
Well, as I said, we're using traditional aviation products, so everything that's in our aircraft has been FAA certified in the past. So, you know, we eliminated our technology risk for the most part and our schedule risk by going with traditional aviation products. The other thing that we were striving to achieve with that is that we want to augment existing manned aircraft so that the manned aircraft can go on and do more important things that require a pilot, whereas the dull, dangerous, and et cetera can be more routine. And so, you know, that's been our real focus for that activity. But the autonomy, the sophistication of the autopilot, the speed in which we could go from hovering in ground effect to hovering out of ground effect to more sophisticated flights has been staggering, because the aircraft just does the same thing every single time. And so the speed of being able to use the automation side has been a great technological advancement because we've proceeded very quickly.
Yeah.
And as the gentleman next to me said, you know, about the AI side, you know, from the detect and avoid, and we agree with him, we're in essence doing exactly the same thing. But ours is a workhorse. It's meant to work. And as part of that, you know, I can give firefighting examples more than I can energy at this time, because again, we're just introducing our product to the energy cycle. But to be able to put our aircraft in a series of aircraft, some people will say swarming, and I was told at this conference that's a bad word, but in a series, and, you know, controlled by one operator for many, the fact that we're working on technology to not only detect and communicate to suppression drones, but also the fact that each time you drop in the fire, the next drone in the path is going to receive different wind conditions. The fire is constantly changing. And so that's the maturity that AI is going to provide for us, is having real time, the next drone in takes a different position and flies differently and hits the fire differently, to be able to try to minimize the effect of fires ever becoming mega fires like you've seen in LA. So that's our vision for that.
Good. So I wanted to flip it down to you, Andrew. Same question, right? And as you guys are growing through your progressions of your aircraft, I'd like to understand from you the same things.
Yeah, sure thing. So, you know, advanced machine vision and artificial intelligence on board your drone, to me, really unlocks cost-effective operations. So that's where autonomy really has to play. So that includes things like DAA, right, detect and avoid. That's a machine vision implementation, or use radar instead. That's going to lead to safety, lead to the platform itself making evasive maneuvers when needed. So that degree of safety means that you can move from an operation scenario with 3 to 5 people for some of these, you know, either extended EVLOS or BVLOS operations, and it can really truly be one operator, one bird.
True.
And then you jump forward even more, and you have several birds and one operator.
Right.
And that's all going to happen through AI and advanced perception and machine vision. So I see that as essential, and it's good everyone's thinking about that, how to optimize that. You know, I consider Skyways as much of a drone developer and manufacturer. I consider us as much of a software company as a hardware company, because we are doing a lot of that onboard intelligence.
Good.
We're using onboard NVIDIA processors. We're actually, when we can define the mission very, very narrowly and specifically, we are flying that completely autonomously. So that means, you know, we've got something called computer vision ship intercept, where we use a training data set to identify which vessel we're looking for.
Wow.
And we autonomously take off. The pilot is there more as a safety pilot at that point in time. And then we say, within this 30-degree field of view, go find a ship. So it autonomously comes up with a search pattern.
Nice.
It identifies the bird, makes sure it's a friendly with its machine vision data set,
Yeah.
and then it can either do an airdrop, a cargo drop, or it can actually do a landing on the ship itself.
Nice.
So
Yeah.
we're definitely forward thinking in that respect. And again, any drone company is a software company and a
Yeah.
hardware company.
Yeah,
Right?
smart, good forward thinking. Mark?
Well, and the other part of that that I appreciate the other comments on is that we as drone OEMs and providers need to take responsibility for the safety of our operations. So if there's a non-responsive aircraft in the sky, we need to take responsibility to identify it and get out of its way. We can't rely on them seeing us, or we have ADSB, so we're pinging and we can catch the larger traffic, but it's the uncooperative GA airplane that we're most concerned about, where they don't even have radios half the time. And so I really appreciate the fact that the industry is taking responsibility for the safety of our operations and our own aircraft. So commend you all.
Yeah, kudos. So I want to change the topic a little bit. I want to get into a regulatory conversation, right? How the new executive order, what we're standing, where we're at. So with the regulatory environment, particularly for heavy lift and BV lost operations, is a persistent challenge. What specific regulatory hurdles are you encountering as manufacturers, and what strategies are you employing to navigate these? So Mark, I'd like to start with you and understand from you how regulatory affects yours.
Perfect. So because we designed our aircraft from the ground up as a light utility FAA compliant Part 27 aircraft, we're used to certification. Our background is in certification. We went through the normal process for certifying any other manned aircraft. We put in our project-specific certification plan. We received a number from the FAA, and they promptly didn't assign a team to us. And that's just the way it's going to be. They've been very clear that they're not going to give us a type certificate to allow us to, without regulation or restriction or any oversight whatsoever, flying in the national airspace. Our aircraft's too big. They're just not going to permit it at this time. So they gave us a path through the operator. So there's a DOT section 44807. We're anxiously awaiting to see what 108 is.
Anxiously.
Yeah. And so, we still can fly public use. We can fly in COAs. We're flying for the military overseas, which is going to and continue to be the majority of our business. Has different regulations in each country. So the answer is that, you have to comply with what's available in the country at the time that they're ready for it.
So to keep this conversation going, I want to kind of segment this because we've got some heavy lift, we've got some long range. So what I'd like to do is jump down to Skyways and understand from you guys in that heavy lift arena how these regulatory hurdles and what you're doing to overcome them.
Yeah, sure. So, there's positives and negatives to this, but we've been DoD focused for, the entire company history. The military likes us for, we're talking Marines, we're talking Navy, we're talking Air Force in particular. They really like us just purely for cargo. So that's what the approach we've taken. So that's where the V2 is the 30 pounds, V3 is the 100 pounds. That is meant for, forward line troop resupply. That's meant for ship-to-shore transport, ship-to-ship transport. And the good thing about DoD is we've been able to get a lot of BVLOS flight hours because these missions we've participated in. We've got a big project coming up in about a month in North Dakota, Project Ultra.
Nice.
We'll be doing some deliveries from Grand Sky to Cavalier Space Force Base.
Nice run.
10 total round trips. So that's really exciting for us. So we're getting those opportunities, but it doesn't translate directly to operating in the national airspace. So that's the challenge for us.
Yeah.
We have secured, as far as FAA permissions go, we do a lot of our flight testing in Giddings, Texas, so about halfway between here in Houston and Austin, basically a big open tract of land, and we're doing all of our testing in this range. So that's under COA.
Nice.
Our version 2 bird, which the development has been finished, we do have a 44807 for our version 2 bird.
Very nice.
And we are close to it with our version 3 bird as well. So we're trying to do all we can, to satisfy the FAA requirements and move forward. Having a DAA system is a big part of kind of our next steps in the commercial arena. So we're looking very closely at 3 or 4 different technologies that could help assist there.
Nice, nice. So being with Unmanned Safety Institute, we have a great relationship with Census Technologies. And some of the things that people may not know about Census is when they sell the aircraft, they're helping people get those BV loss waivers. So Kyle, if you could touch on that and what you see for Census and also the clients that you're helping obtain those waivers and get around the regulatory environment.
Yeah, we recognized pretty early on, like 2017, 2018 timeframe, that if we wanted any chance of selling this thing at scale, getting this thing into these enterprise organizations on the commercial side, so we almost 90+% of our business is on the commercial side. I mentioned energy transportation, that's a lot of electric, it's a lot of oil and gas, a lot of DOTs. If we can't let these folks, the phrase I always use is take the Ferrari out of the parking lot. If they can't take the Ferrari out of the parking lot, is it worth buying it? Probably not. So, we focus pretty heavily on enabling initially it was the BV loss operations, and we still do that to this day, but that's gotten so standardized over the years. So one of the hurdles that you mentioned is really, this is the opposite of a hurdle, but shielded operations we've really leaned into that to address the air risk component to flying BV loss. So how do we safely integrate into the NAS? Well, shielded operations is a way to do that. Flying shielded, meaning we're only a certain altitude above what we're flying over. In the energy sector, that's typically 200 feet above a transmission line, for example. Or the adjacent infrastructure to the left and to the right. So if the trees are taller than the infrastructure you're flying, you're 200 feet above that. So that's a way to mitigate air risk that we've really leaned into. There's been conversations or stuff on the stage so far about detect and avoid. We leaned into that technology pretty heavily early on, and it's been definitely a contributing factor to the safety case over the years. We use an optical system. You mentioned radar, so that's on the roadmap. It's something to look into, maybe. But we've been integrating the optical detect and avoid from now UAVionics for 5 or 6 years. So that's been a tactical mitigation all along the way. But shielded operations has really been a big opportunity for end users to fly these things long range, 100 miles plus. Back in the day, 3 miles plus, but now in that 50 to 100 mile range mark. So, that's why I say technology and regs are kind of coming in concert. And what we're working on now is greater permissions for operations over people and moving vehicles. So, taking the drone out of the test site, out of the sandbox, Sahara Desert, nobody around to hurt, nothing flying. There's limited value there. Limited economic value in that tight of a sandbox. And if we're in the commercial arena, we don't have the flexibility of DoD restricted airspace to do whatever we want. So, and we're largely U.S. as well. So internationally, we take this the safety case, SORA-based safety case, and take it overseas where it also applies. So that's the big thing for us next is getting an ASTM certification for our parachute, so we can fly over greatly, densely populated areas. Maybe not Brooklyn, but neighborhoods adjacent.
Densely populated. Yeah. So to move down the panel, same question, but coming into this country and standing up operations in business here in the United States, how does not only these FAA regulations affecting your business, but other regulations, how do they affect your business here in the United States?
So we are a Swiss-based company. So accordingly, we have some plus in our flag, but not only that, there are also a lot of other Swiss drone companies, and we have some perception that the drone is good because if it is from Switzerland, but we have also considered in the design safety aspects, and that helps a lot because those safety aspects are not only so there are regulations, but all the regulations, they want to have safety all over the globe. That's why we have them. And we have safety aspects in the design implemented. So we have at each, it's a multicopter, our drone. So each arm has 2 rotors. So if one fails, we can still bring back the drone. And this is already a tick box for regulatory authorities that you have implemented safety in the drone. We have an engine. It's a hybrid engine drone. So if the engine fails, we have a backup battery to land the drone. And we have a tank system which is redundant. So if one fails, the other tank will still provide fuel. And these are concepts which are globally the same because it's just technology.
They are,
and it gives you safety. The other thing is We are working closely with a company who has a test area for BV loss operations, and they are flying our aircraft whole week.
Yeah.
They are just flying, doing nothing else than flying to get these bloody hours onto the aircraft, because of all regulatory bodies, if it's EASA, FAA, Transport Canada, CAA,
About the case study, Dave.
they want to have a safety assurance
Yeah.
proven by ours.
Yeah.
And we are a young company.
Yeah.
We are just out in the field 2 years. It's hard to find customers who will do that for you. So what do? You
Yeah.
spend money into that.
Right.
Thanks.
Yeah, it makes it interesting to operate, right? So to move a little bit on, I want to talk about operational integration, and working down the panel. We'll start with Mark again here. For energy companies looking to deploy these advanced drones, what are primary considerations for operational integration?
So again, as an OEM, we don't operate our drones. We work with our end-use customers to operate the drones that understand the regulations in which they're operating in. And so we work with them to integrate into their existing flight activities. We don't change them. We literally just have an aircraft that is absorbable into their normal operations. And again, we're at a kind of a different end of the spectrum. We're at the high end, so it is any entity that operates a current manned aircraft can operate ours. We have no launch and recovery systems. There's just literally zero difference between a current existing FAA approved manned aircraft. And so there's no change in infrastructure. So those are the things we did, in the activities we're doing. And then our control systems are just configurable. So we have an extremely sophisticated autopilot that comes from Spain, and yes, approved. And it is configurable. And so we're a multi-mission aircraft, and that's literally what it is tell us about your mission. We'll work in training your staff. But it is just a matter of configuration.
Very good. So what about Skyways? So what is Skyways doing to address this?
Yeah, so again, commercial applications are quite new for us, again, being DoD backed, but we have had 2 great successes over the last year or so. So we currently have 2 of our version 2 UAS in the UK. We've partnered up with Skyports, who's doing the operations.
Yeah.
So,
Good partner.
we're basically doing, trying to keep that line of focus on what we're really good at, which is developing and manufacturing aircraft. So it's always those drone service providers or those helicopter operators who we want eventually to do the work with the drones that we provide.
Yeah.
So Skyports is exciting. There's a handful of missions that they're supporting there, all proximal to the UK, North Sea, English Channel areas, and then another one over in Japan. So we've got a large operator there who has 2 of our version 2 birds, and they're also flying missions right now. And that's a combination of some defense support and straight commercial support. So you can tell the trends there that, we are going to these areas where there's more of a history of getting BVLOS approvals. The UK is very reasonable. I did some work way back with a pioneering company in this space called FlyLogix, and they were flying, 12 nautical miles plus from the coast, right? High seas operations, and they were getting those approvals.
High seas.
Yeah,
Big environmental changes out there too, right?
Yeah, sure. So that's really the approach we've taken. So again, those 2 early commercial successes give us a lot of confidence that we're continuing to provide value.
Nice.
Yeah.
So to stay on this integration piece, Kyle, with me being involved with Unmanned Safety Institute and training American Electric Power Up and hearing what they're doing with the Centero 5, what they're doing with the 6, I'm curious to hear from you how Census has seen in that integration piece of training their pilot team up and making sure their safe operations are running.
Yeah, it's a good question. I mean, one of the operational integration thoughts I had when you brought up that question was, I already mentioned it, but the back end. How do you consume the information? Are you using onboard AI, post-processing AI? So I won't hit on that, but you bring up training, and it's a good one. Some of the first questions you ask is, what's the end state? Starting from an inspection velocity cycle. We work with some utilities that have a 5 to 10 year inspection cycle. Some of them haven't ever looked at a pole since it was put in the ground. That's really a lack thereof inspection program. But that's not a desire. That's just a function of how many resources they have and prioritizing work that needs to be done with the resources they do have. But what in their utopia, what does it look like? Are they seeing every asset every 30 days, every 3 years, every 3 months? Like, what is that end state? And that answer is a moving target depending on who you ask. And then how do they envision getting to that end state? Is it by hiring 200 pilots? Is it by upskilling and reskilling folks from different business units?
Yeah.
Operations 100% internal.
Yeah.
Operations 80-20, where 20 is contracted out. Operations are 80-20, where contractors do 80% of the work. What is that ratio?
Right.
What's ideal? And that answer doesn't need to be firm and fixed. It will shift over time as technology changes, as leadership changes.
Right.
Someone retires, and next thing you know,
Right.
the whole strategy gets thrown out the window.
Absolutely. You see that a lot, too.
Or somebody retires and the whole program gets to actually start.
That's true, too.
That's the case
Yeah.
sometimes, too. So, you have champions that are moving some of this stuff along internally, and they're blockaded because they have, whatever political stuff going on inside the organization. But, that's the questions that we always want to ask, besides how do you plan on ingesting 500 miles of data a day or 300 miles or whatever the number is. How do you plan on ingesting that information and actioning off of it? And then how do you plan to collect it? Do you plan to do it all internally? If so, that's incredible, fantastic. Thankfully, there's tools in place to do it.
Yeah.
So those are the main things that we ask. How do you integrate operationally? Those are the questions we ask.
Yeah, good. So I want to talk a minute about emerging use cases, right? So I live in North Texas. I've been fortunate enough to be involved in standing up the package delivery with Wing and them that are there. So I want to talk to you guys, especially we'll start off with the heavy lift guys. And Andrew, I'd like to come to you. How do you see the emerging technologies and how your aircraft's going to fit in with this middle mile type delivery of cargo?
Yeah, so we're really trying to find those use cases where that extremely long range, and moderate payload capacity really make us outstanding amongst the small UAS, the sub 55. Yeah. So we're really focused on pipeline inspection is a big one. Long linear, everyone up here I think is looking closely at that market. Yeah. The ability to map extremely large areas, instead of field scale, you talk about territory scale with LiDAR or some other sophisticated instruments. So we're not really looking at the short logistics. Our version 3 can get 1,500 miles of range. That's fully loaded with fuel. So that's a situation where you are talking about going across the majority of the United States with those types of ranges. We envision kind of that scenario for us. Think about offshore oil and gas. We want to set up a partnership in Louisiana where we're doing this on-demand delivery. It's going to be landing on helipads. It's going to be deconflicted with the existing manned helicopter traffic. That's the type of situation where we feel like we can service all the oil and gas companies with the right range, with the right characteristics.
That's the project I was involved in too. There's a lot of opportunity in that resupply, and not just for inspections of the rigs, but getting day-to-day operation cargo out to them is a big piece.
That's right. And one other thing, if I may, we're hearing a lot, our cargo bay, it's just a big empty space, and we've got a lot of onboard power. Yeah. So a lot of the discussions we've had at AUVSI and here have focused on, okay, what do we want to instrument this with to give even greater value? So I've got a lot of experience in methane detection, gas leak detection. That's something we're looking closely at. That, of course, relates to the pipeline leak inspection. Yeah. And that's putting together those kind of standard packages, I think will really help us help all of us get the commercial traction that we're looking for.
Yeah, that's interesting. Even with the changes with EPA and methane testing out on the rigs and all of that too, that's all playing a big piece. So Mark, I want to come back to you about the emerging technologies and this heavier middle mile type cargo. Do you see that impacting you, or what do you see in that?
Well, the example that was just given is relevant to us. Yeah. So again, we have a very large payload. So in an emergency response, instead of trying to figure out how to get through the streets with litters of trees and stuff to bring a transformer that is blown that needs to be replaced, we can carry it. We can carry multiples, and not only that, we can carry detection devices. We can carry other instrumentation on there. So it is a multi-use aircraft. It's meant to do a lot of things, but primarily it's a workhorse. It's not so much a data collection, but it is to be able to help the response and rapid reconfiguration to be able to get power back. The offshore case, just taking mechanical and components back and forth. Lighter weight versus heavy. To have a pilot do that, we can do it 24 hours a day, 7 days a week. And the platform doesn't move. So once you create your autonomous algorithm and you have your route approved by the authorities, it literally is a button push. And our engine can be started. It's a jet engine. It can be started from anywhere in the world, and that whole mission can be carried out autonomously because it is one of those dull and routine, and you don't have to risk your human factor in doing those routine missions.
Yeah, great. So I want to change it up a little bit. I want to talk about one of the pain points in this industry, no matter what you're flying, it's power, right? Whether you're electric or you're hybrid, or it's a problem, right? So I want to start with XCR and considering the need for extended endurance, what do you see are the next frontiers in power generation or storage for drones?
Can you repeat
Better
the question?
batteries? Do you see a generating system? What do you see as in power?
So our drone runs on gasoline. So the next thing which I see there is that you get that gasoline carbon neutral, so that you use sustainable aviation fuel for that. And then batteries are getting better. So, and we made that calculation. So we fly for 2.5 hours with 2 gallons of gasoline. So in order to do that with batteries, we need around 120 pounds of batteries. And our trust just let us take off 66 pounds. So what does that mean? You need a lot of development and get a higher density per pound on the batteries. So this will take another 5 to 10 years until you are there. And once the batteries are there, we can switch to that. So it's not about it's gasoline or battery for us. It's about making possible to fly BVLOS today to get operational efficiency, which gives you also some less moving around and enables that you have a better climate as well because you have less emissions. And fuel cells is a viable option. They just need to get a little bit lighter.
Yeah.
We looked also into that option. So a fuel cell is heavier than our engine if we want to get the same power out of it.
Yeah.
And I assume this will happen faster than batteries. But that's my personal opinion.
Have you guys experienced? Have you played with like hydrogen and other
Not
solutions?
hydrogen.
No.
In my previous career, I was playing with methanol, which is liquid.
Interesting.
And there are direct converters which can convert methanol into hydrogen, and methanol is liquid. So the logistics is much easier if you use that.
Oh, yeah, much easier. Interesting.
So I see a potential there as an electrical engineer. And having looked into that technology, we will see what the future brings.
Yeah, we need. I always tell students I talk to, we need an Elon Musk in the battery industry to develop something, right? So Kyle, for you, for this, let's say Centero 7, 8, what are you guys looking at? What are you thinking about for power to extend those flights even longer?
Yeah, honestly, I'm not our CTO, so I can't speak on our technical roadmap with absolute authority, but I have a hard time believing we're going to move away from batteries.
Yeah.
We enjoy a reliability factor that comes with not having an engine.
Yeah.
Again, we do sacrifice things like payload capacity, things like endurance, but we're serving markets that are different than these guys in some ways.
Right.
Not different in every way, but I wouldn't view anybody on this stage as a competitor.
No,
because we're
absolutely
serving, even though the customer might be the same the business unit we're serving, and the use case is different. So
That's what makes the panel unique, because it's a different flavor for
Yeah.
each one of the aircraft.
And the way that we look at it as well is there's more than one voice in the room when it comes to large scale platform
Very true.
acquisition. Nothing on this stage is cheap. I'm going to assume.
Very
Never seen a
true.
quote from these guys, but I'm assuming nothing's cheap. There's more voices in the room.
We can give you a quote.
There's more voices in the room when you're going through the acquisition process or procurement process. There's risk management. When most of the groups that we're working with are fairly risk averse.
Yeah.
Utilities and oil and gas, they're fairly risk averse.
Yeah.
If you have service territory in high fire threat districts,
Yeah.
there's considerations for that with different types of technology they're looking to buy. Aviation assets they're looking to buy. Is it fuel burning? Is it battery? Everything can start a fire, but different folks look at different technologies different ways. So I believe batteries getting better would be sweet. That would be
Thank
huge.
you. Yeah.
But I don't have any insight into whether or not we're going to go to a hybrid power plant.
Yeah.
The way that we're looking at kind of rapidly deploying these electric systems all over the place and is recharging through dock solutions. So drone in a box for Centero 6. We had one in Houston a couple weeks ago.
Yeah.
Adam had the
If you
privilege
guys haven't seen it, you should look at the Centero 6 dock. It's a pretty awesome solution.
Adam had the privilege of driving that thing back and forth from Daytona Beach to Houston. So we didn't bring it this week, but that's how we look at kind of getting the most out of that, recharging and redocking every time, dock hopping and networking those things together.
Andrew, for you guys at Skyways, what do you see this? What are you thinking about for your next evolutions?
Yeah, so starting off our work with DoD, it was always about that maximum range, high endurance. So we always were to meet those requirements. We've adopted a hybrid power system. So we have a heavy fuel engine, spark assisted, made by Northwest UAV. And we've got a very close relationship with them. So our powerhouse, that relationship I think is critical to all the progress we've made to date. Very reliable engine. We've got about a 5 horsepower on our version 2, and I believe it's an 18 horsepower on our version 3. We are VTOL in transition, so we do have an alternator on our power system as well that's recharging our batteries. So we take off electric, transition to forward flight, and then we land electric. We're not using our lithium batteries for anything like a hover mode. We're always in forward flight during the mission. And that's one reason we're getting such amazing range on our systems. Yeah.
So as we're getting towards the end of the session here, I want to come back to Mark. And I want to talk to you about collaborations. And we'll go down the line, but I'll start with Mark here. What initiatives are you involved in, or what partnerships do you believe are critical to accelerating heavy lift drones in your aircraft?
Well, for us, it's all of them. So again, we took a best of breed strategy in our selection of the Rolls-Royce engine, 180 million flight hours on it. There's nothing more proven than that platform. But in our rotor system and the avionics that we use internally, we went to vendors that are already producing it for other people. So, we continue to focus on the fact that there are thousands of companies literally out there developing technologies, and we can't possibly be able to support the major technologies that are being produced. But we have the unique advantage that we're the one who gives them a ride.
Yeah.
So those entities that are out there need OEMs like us to hang stuff off of, whether it be cameras or sensors or mission equipment that do things like, we can install a power line insulator washing system on our system. We've done it in the past on manned aircraft. So the fact for us, and I'm in charge of the teaming for our company, I am constantly looking for innovators that have neat technologies, because I know a lot of the end-use market, not so much the oil and gas, but predominantly in other civil applications, we know a lot about what the operators need. And so when we see neat technologies out there, we can bring them to those operators and work with them to integrate them into our aircraft. So the answer is that we have no limitations. We have extra power, we have extra lift, and we design that into our platform on purpose because we know things are going to continue to migrate and change. So I strongly encourage the teaming approach, and from my perspective, just like we talked about here, not being competitors and stuff, but a high tide raises all ships.
Yeah.
Okay, you're getting good BVLS operations. You're working on optical, and I mean, all of this is just phenomenal for our industry and for our end-use customers, which means our citizens and our customers' customers. So, I think it's essential.
Yeah. Thank you. So how about for XCR? How do you see that?
Yeah, I believe the drone industry doesn't locked off yet its potential. So there is a huge market which is waiting for us, and we need to open that market which is not yet approached. So there is a market above 55 pounds and beyond visual line of sight.
Right.
And you can do that only if you partner up with the whole industry. So you need to find the right payload partners, right consultancy companies who do regulatory stuff,
integration,
training,
Yeah.
like USI, and we need to make the preach all together here.
True.
And talk to FAA, talk to politicians, talk to the industry that we have the solution here, and let's do it together.
Yeah.
All together, integrate
message.
seamlessly, and make it possible.
Yeah.
And that's why we are partnering up with everyone almost, and we share our know-how and knowledge to make things and improve it, so that we have better efficiency, better data,
Yeah.
actionable data insights.
Yeah.
Yeah.
And I know for those of us at USI, we appreciate the collaboration with you guys, right? Because it's helpful. Kyle, to you, how do you see partnerships, and what are you looking for or thinking?
Yeah, for us, payloads in C2 are probably some. I mean, it's been said
Yeah.
up here, but everybody's flying this stuff to bring something somewhere, and you need communications to do it. So, things like satellite C2 is on our roadmap as well, because we're currently LTE and radio based combined. There's still limitations there.
Yeah.
We're throwing the other two COT solutions
Yeah.
at it, and there's still limitations. So, there's areas where there is no C2, and then if you are operating just off a radio, you have a reduced range compared to whatever power you're pushing with directional antennas and the other rest of the radio magic. But and then the other side of that is you're only as valuable as what you're carrying payload-wise if it gives the deliverable for the customer and why they're flying.
Yeah.
That's what makes you valuable as an aircraft OEM. So payloads in C2, and then you mentioned on the regulatory side that kind of teaming thing. I think what's been interesting is when we write these waivers for people, again, half the time it's free because they're
Right.
buying the plane.
Right.
So we don't charge them for that, and it's the other half of the time it's pretty cheap. But they own that. They paid for the right to have that template and grow their own program with their own regulatory set of permissions, add systems to it, add other drones, meaning expand the operational envelope, request new things from the FAA. It doesn't scale for our customers to constantly go to Census to ask for regulatory support.
Right.
It does once,
Right.
and we can help you once, and we're
Right.
happy to, more than happy to. But long term, it's better for us if our customer can take that and run and
Right.
grow their program, have a
Right.
need to fly more things, buy more things, et
Right.
cetera. So
Build that relationship.
Yep.
Yep. Good answer. Andrew?
Yeah, so not so much a partnership, but in terms of us being aware and out there looking for all the new technologies that will improve our technological offering. Starlink Mini has been a huge game changer for us. So
Yeah.
every
Yeah.
single one of our birds right now has a Starlink Mini right in the
Yeah.
top of our aircraft.
We see that as operators in remote locations, so you need those comms.
Yeah, and
You're
that
right.
gives you the redundancy.
Yeah.
It gives you the amazing streaming
does,
video. That's been huge for us, right? And really, that redundancy is needed for anything FAA related, right? That's going to be one of your safety cases that they're
Yeah.
evaluating. So we're really excited about that. So we're always willing to make minor modifications when it improves our aircraft.
Nice, nice. So I appreciate all of you guys' time today. Great selection of knowledge. So I want to close this out, and I'm going to ask you a question. We'll just start with Mark. We'll work back down the line. So what's your boldest prediction for 2030 that you see for heavy lifts in your aircraft, or maybe in particular on what you're doing with your aircraft? So starting with you, Andrew, what would you say is your boldest prediction?
Yeah, so the way we see the world, in terms of how this industry is going to evolve, in terms of, what you're carrying, right? So sensors first. We're all flying with sophisticated sensors, probably these other companies more for us that are more supporting the commercial side. Sensors first, cargo second. So we're amidst that stage right now, right? A lot of cargo delivery, and then people are going to be third, right? So
Trained workforce.
You don't fly. I always like to say you don't
Right.
fly with the most valuable cargo, right? We're all biased there, but most valuable cargo being human as the first con op. So that's another reason why we're working our way up. And then in terms of where you can do these operations, now the last mile delivery is working a lot differently, kind of in the inverse of this, but maritime operations for BVLOS with these Group 3 UAS is going to be first, right?
Yeah.
Safety, a lot less risk of collateral damage. So that's
They
where
have
we
the money
see.
invested in the R&D too, and to test and push the realm. And,
There you go. There you go. Yeah, but pure safety case, maritime's going to be next, and then you move to those more advanced kind of over terrestrial operations, which will be the hub and spoke model eventually. So that's really the strategy we've taken, and again, evidenced by North Sea operations and Western Pacific operations on the commercial side. So I'll break.
Kyle, for Census, what do you see?
Well, I don't know how bold this is, but I see a networked solution of drones and docks between multi-rotors, and which we don't make, and fixed wings, which we do. All, whether they're owned by something like a municipality or a utility or what have you, these are networked together. And I'll give you an example. We work with 3 or 4 utilities in the Northeast. All their service territories kind of overlap. It's all not that big geographically compared to even just Texas, right? The Northeast, the states I'm talking about are pretty much just smaller than Texas still.
Very populated.
Even it's a cluster of 6 states combined. It doesn't take that many drones and docks to cover every single asset in those states. Rail, waterways, distribution lines, transmission lines, bridges, tunnels. It takes a variety of different solutions to do all these things.
True.
But I see these solutions being shared solutions. Whoever owns and operates them, that's TBD, and that'll matter, or that'll be dictated, in the future by who bought them and all these other things. But I see these assets being shared and networked, and you're requesting flights.
Yeah.
And these assets are being flown all around the county, the city, the state for a wide variety of reasons. And they might be being tapped on by the Water Authority on Monday and New York Power Authority on Tuesday. So that's kind of how I see it. And again, I don't even think that's that bold.
Safe, but true. Right? How about for XCR? What do you see? What's your prediction?
I see that for sure. Unmanned, whatever it is, it can be aerial, it can be undersea, it can be oversea.
Right.
There will be a crucial change in decision making. So the robots, they will start to make their own decisions based on AI, and this will help to do autonomous flights. So there will be less the manual flights.
Yeah.
And the more you do autonomous flights, there will be more demand on robotics.
True.
And the more data we will get, and the more actionable data will be out in the market. And that's what we are working a lot on. That we have the onboard power to give the capability to do that decision making.
Right. Good.
So, and that you have the connectivity also when it comes to bandwidth, because you might need to get at certain stages some data directly from the cloud and then process it on board of the robotic device. And I see there also an advancement in that regard, that SATCOM will be better in the future.
Yeah.
So that you have higher bandwidth, and this will help to have more data shared while you are doing your mission.
And we can do a whole session on data. We barely scratched the surface on
Yes.
data, right? So for you, Mark, what is your boldest prediction, or what do you see?
Well, no one can stop the fact that UAS and robotics are going to be ubiquitous. It's just going to continue to grow, and no one's going to stop it. So you can either jump on board or get kind of crushed in the wake of it. And that's what this whole panel's about. But
Right.
I'm going to. Yes, integration, not just with flying aircraft, but with the ground activity as well. So, even within factories and things like that, there's just going to be more integration, more smarter, as AI continues. And I mean real AI, not just automation of something. So they're just going to learn more. But I'm going to take a regulatory approach to it. I believe that the regulatory agencies are going to continue to develop not just the 108 rules, and they'll do it slowly, but they've got to start approving activities within the national airspace, and not just for existing proven technology like we're using, but for transitional flight,
Experimental.
and
Yeah.
batteries,
Yeah.
and some of those technologies that are being used today at a smaller level. They don't have certification rules for
Right.
flying in the NAS, and that's
Right.
got to change. And the activities of all these gentlemen, working in that environment is going to continue to propagate that. So I am going to boldly say by 2030 that there are going to be aircraft approved in the NAS.
That's a big gamble that the FAA is going to get their stuff put together by 2030.
90% of that
Good
is
bold
hope.
one,
but I'm going to take the hope as
Yeah.
and continue to work within the industry to make that a reality for all.
Yeah, we all hope for that. For me, I appreciate you guys' time today. Let's give it up for these guys. And then I wanted to open it up for a few minutes to see if there's any questions in the audience, if you guys had any questions for any of the panel.
You guys covered a lot of ground.
Yeah, and there's so much we could have
Hang
done
on.
2 more hours on it.
Yeah, hi. I'm curious with the autonomous vehicle industry already having resolved a lot of the issues of object avoidance because they operate in very congested environments. Do you think there's some cross-pollination that we'll start to see move between the two modalities of transport? We've got obviously they can work in a more innovative environment because there's states like Texas where you can basically do whatever you want. You don't have to deal with the FAA to get approval for it.
Yeah.
So I'm just curious, do you see there starting to be some convergence between these different AI and autonomous systems where we start to see people develop integrated devices that are using technology from, say, a different modality?
Yeah, good question. Any of you guys want to hit that?
Yeah, I mean, hopefully this is kind of an answer to that. But I had a meeting yesterday with a major gas station, and they want to use drones to act as a deterrent. They already have active alerting systems for some of the higher threat stores, I guess. These are fixed installations on the buildings that if they did catch a loiterer or someone's been hanging out too long or what have you, something buzzes and tells them to go away. I guess that hasn't been enough. So they want to use some kind of multi-rotor dock solution, and upon which we are not. But from a regulatory perspective, we can kind of help shape some strategy here. And they want to have that ground-based sensor, that building-mounted sensor, trigger an autonomous flight from the drone to basically fly 30 feet away from the person loitering and light them up with a spotlight and speaker and play an automated message. And bad time to be a loiterer, I guess. But that's the type of time between ground sensors and airborne vehicles that I think is hopefully an example, and that's already happening. So,
Yeah.
I don't know if that was like a 5-year
it's already
question or
happening.
do you see that happening in the future? But I
Yeah.
think it is absolutely the only
Yeah.
path forward for a full integration of robotics, like Mark said. So,
Anybody else have a comment?
Yeah, I mean, what is crucial here is that we need to have this unmanned traffic management system,
Amen.
and then any unmanned drone can send the information which they catch, what is around, feed it back to the system, and all the other aircrafts up in the air will know what's happening.
Yeah.
So that will trigger it, and I'm seeing it happening. There are some test fields already there,
Yeah.
and this should be spread out in the next 5 years. So we have the ATM, and we should have definitely a UTM.
Good. Any other questions? Great. I love it when we answer all your questions. I love that. That means it's a successful session. Well, thank you all for coming. We appreciate your time today and letting us talk to you about long-range and cargo drones. Thank you.
Thank you, Michael. Thank
Yeah.
you, panel. We really appreciate it.